Hello everyone, welcome back to more Advent of Code 2020. We're going to be doing day 23 today in Haskell, as always. Anyway, as always for this year, I've done it, as I think I mentioned before, I've done it in Clojure 1 year, and 1 year in Python. I think that was the first year I did videos for it, I'm not totally sure. Anyway, day 23, Crab Cups. The small crab challenges you to a game. The crab is going to mix up some cups, and you have to predict where they'll end up. The cups will be arranged in a circle and labeled clockwise. For example, if you're labeling with 3, 2, 4, 1, 5, there would be 5 cups. Going clockwise around the circle from the first cup, the cups would be labeled 3, 2, 4, 1, 5, and then back to 3. Before the crab starts, it will designate the first cup in your list as the current cup. The crab is then going to do 100 moves. Okay? Each move, it does the following. It picks up the 3 cups that are immediately clockwise of the current cup. The 3 cups that are immediately clockwise. Okay, does this include the current cup? I forget. We'll find. As always, I read this puzzle and I don't remember the answer, but there's an example. So cup spacing, yeah, of course. The crab selects a destination cup. The cup with a label equal to the current cup's label minus 1. If this would select one of the cups that was just picked up, the crab will keep subtracting 1 until it finds a cup that wasn't just picked up. If at any point in this process the value goes below the lowest value, it wraps around to the highest. Fine. The crab places the cups it just picked up so that they are immediately clockwise of the destination cup. They keep the same order as when they were picked up. The crab selects a new current cup. The cup which is immediately clockwise of the current cup. Okay. So our current cup here is 3. It picks up not the current cup, but only the ones that are clockwise from it. So 8, 9, 1 in this case. And it says, how does it decide? Oh, it decreases from the current cup number, which was 3, so it finds cup 2 and moves the 8, 9, and 1s. They come right after the 2. Yeah. So the 2 just kind of hops over all 3 of these. And then we pick up 8, 9, and 1 again because they happened to be. Wait. Because the current cup happened to be the one right after the original current cup. You aren't going to get the same numbers every time. Anyway, here we picked up 8, 9, 1. We decided to put them under 7. And we moved on to 5. Immediately clockwise. Yeah, okay. So our input is very small. It's only 9 cups. And I'm not actually sure what the right data structure to use is here. If we had a sufficiently large input, then it would make sense to pick something where shifting is cheap. For example, you can use data sequence. It's like it has good enough amortized performance for almost anything you can do with sequences or with indexed containers in general. And so it's a good default choice. If we had like 1,000 cups, for example, it would be very expensive to pick up 3 cups and then shift all 997 of them to make up for that difference, right? Or, okay, on average, half of them. But with like just 9, you could honestly probably even use a list if you wanted. Or an array? Because, like, what are the operations you have to do? You have to, like, starting from a position, we have to choose 3 indices, which are very easy to compute. Like, we don't even need to reference the array. We just need to know its its size. the 3 indices immediately after it wrapping around. And then you need to be able to it's actually, if you use just a simple array, it's a little bit tricky to figure out how to shift things, actually. Because if I get rid of like these 3, for example, simple. You just take everything that comes after them and subtract 3 from its index. And you move it down by 3, right? But what about here? Or maybe better here. I don't know. They're both fine. You take 3, 6, and 7 and you pick them up. And so what the heck even happens here? Like the 2 gets shifted down by 3, kind of, right? It winds up, no, it gets shifted down by 2 because one of the values being shifted is already to the left of it and the others are on the right. I don't know, it's super weird to think about this in terms of manipulating indices and shifting stuff, right? Whereas I think it's much simpler to think of the problem as deconstructing, like tearing apart and reconstituting sequences. If you say, okay, we'll form a sequence that's, 3, 6, 7, which is not really a proper subsequence if we view this as a list whose initial element is 7, but it's not that hard to do. With data sequence, you could remove those. You could construct the 2 sublists, one which is like what comes immediately after the 9, and one which is whatever is left over, whatever, a prefix of the original list that is large enough to make up the deficit that you couldn't get from the suffix. Concatenate those 2 lists together and remove them from the original list, and then plonk them down in their new position. I think is reasonably simple to think about compared to messing with indices for everything. And it has good asymptotic performance, although it doesn't matter since our n is 9. Okay, so we would be saying 9, and then it picks up 3, 6, and 7, and it decides to put them after 8. So if we remove these, yeah, I think it's nice to just model, to actually model what's happening in the description of the problem, instead of trying to implement the most efficient shortcut for getting the same behavior as what's happening. I think that's a nice principled approach. Okay, so anyway, here we are in, and I can look at our input, which, there you go, we saw it already. So what do we need? Well, we certainly don't expect to need applicative do. Might need lambda case, who knows? Let's import data sequence seek. And as I recall, we usually want to import some constructors, deconstructors as well, although I don't know if we're going to need any of them right now. Let me look at data sequence. I'm actually a little surprised that when I search for data sequence, Google gives me Haskell's data.sequence package. Does that happen if I search in incognito mode, for example? Well, it does. Okay. I don't know. You would think that's a generic enough set of words that it could have that there might be some more generic, like non-Haskell related thing. Haskell's niche enough that searching for those two words should like give you a Wikipedia article or something on a sequence of data, but apparently not. I don't know. Feel free to search for it yourself and tell me if you get different results, in which case like incognito mode is being contaminated, which would not be a surprise. It's a pretty imperfect layer of separation. Anyway, so like what exactly do I need? I have deconstruction, view R and view L. No. Yeah, I just like, I don't know, I don't see myself actually, I'll be like using from list to make lists of 3 elements and, you know, concat or however you, how do you deconstruct? Yeah, but that's not what I don't want foldable. How do I like split? Sublists? No. Indexing? Take and drop. Okay, that's sort of what I want. Yeah. It's even got elem index L. That's so perfect. Because the tricky thing about what's happening here is if we just add stuff to the front of the list, if we were maintaining, say, the index of the current cup between iterations, it would be easy to get lost, right? And so it's much better to just keep track of what is the label of the current cup, because that doesn't change when the crab does its stuff. And then just like once you're done moving things around, find out what comes after that. Elem index. What's the difference between elem index and find index? Oh, I see. Take the predicate instead of just equality. Sure. Yeah, I don't think I need anything else from dataseek. Like, I don't need the constructors, which are kind of nice to have short names for. I just need its functions, which using them qualified is perfectly fine. Okay, so what is our input then? I suppose it is a seek of int. And I guess we should bake in the assumption that our input is single-digit characters. How do you turn a character? Is it like digit to int? Let's ask Google. I have a char and I want an int. What are my options? I know I have like ord, which is not what I want. That'd give me the ASCII value. But I want like the character 6 to give me 6, if that's all right. Hello? Digit int. Okay. And that's in data char. Not a surprise. That's what I thought it might be called, but okay. Import data char digit to int, and I think that's probably all we need. Parse is s from list map s digit to int init. What happened to my Emacs process died for some reason? Not my GHCI process. I didn't even do anything interesting, I thought. It died again. Just when I said to compile the file. What's going on? L? Didn't find expected autogen file. Cannot satisfy package regex applicative. I don't know what changed. I don't need regex applicative today, so I can just get rid of it, but like something weird going on stackage, maybe? I really don't understand how Haskell's stack and cabal work together. Anyway, getting rid of those unused packages solves the problem. And there's prepare, so that's simple enough. We can test prepare of 1, 2, 3, 5, 7. The list. Oh, right. This is wrong because our input always has a new line at the end. You know what? Actually, let's just instead of init, we'll say remove or filter not equal new line, and that's like a little bit more robust. Now this works, and this also works, even if there were no trailing new line. Okay. And our like game state, I guess, is a useful function. I usually put that above the input, don't I? Game state is a game state of seek int and current label an int. Or is it better to keep a current index? I'm not really sure. What are you mad about here? Oh, I used the wrong trace. Okay. Because the current cup starts as the leftmost one, right? Yeah. Which is fine. So maybe I should make my input actually be a game state. Game state sees first where sees s first is head s dot head sees s does not support head. Okay, what is the first item in a sequence? I mean, I can just look it up by 0, I guess, but I should just we'll just pull this out. Head digits. There you go. And so I think all we then want to do is write a function from game state to game state, right? Advance game state, advance game state. I'm a little annoyed actually because like I still don't really understand the right time to use records or what extensions you're supposed to use to make records tolerable. Anytime I pick a good name for a field, I find myself shadowing it all the time, and then HLint gets mad. And I don't want the record to have the accessor functions, but more as just like documentation about the meanings of the fields. Like if I could get rid of the accessor functions, I would be perfectly happy most of the time. Okay, but I'll just shadow it and, you know, fuck you, HLint. That's my opinion. Label, there you go, equals something. Well, we have the label, so let's just like let some stuff and work our way towards something useful in that direction. We certainly need to know the index that contains the current label, right? Let just index equal s dot, what was this called? lm index L? Sure. lm index capital L? Capital L, yeah. Current label cups. So now we have the label of the current thing. And let's let our size be the amount of the... Ooh. I just had this like thought, what is part 2 going to be? It could just be like do more iterations instead of 1,000 or instead of 100. But it could also be like, what if you picked up 5 cups instead of 3? And it would kind of be nice to make this function a little more easily parameterized. But I guess for now, we'll just have it be a constant 3. I don't know. Let's just find a constant for that. Num cups picked up. Call it moved. 3. There you go. Our size is so let's see. The first index obviously is 0. So if we look at our current index, the number of items that are to the right of it, not including itself, should be the size of the cups minus the index minus 1. Yes. S.size cups minus index minus 1. L size is num cups moved minus R size. That's how many we will have to take from the left end to satisfy the constraint that we always pick up exactly num cups moved total. So now, and often it will be 0. If the cups we're picking up don't wrap around, fine. So, next, I think I should split the list, right? And we said that like take and drop are the way to do that. We have split at. Do I want split at? I think I do. Because otherwise I'm going to just repeat take and drop at the same index, which is stupid. So now I'm going to split my list into 3 pieces, I think. But I have to do it with 2 separate splits. Before remainder is S split at L size yeah, this is fine, of cups. So now how big is my remainder, right? The index that I use for our side, like, I can't just use the original index as my starting point for where I'm dropping. Oh, although I totally could if I did things in the other order. That would be much simpler, wouldn't it? Yeah, it would be. Okay, so let's maybe say left picked up is s dot split at r size, right? No, not at all. Let's pull this into a variable. We're going to use it like a million times. Size equal, well, actually, I don't know how many times. We're using it at least once, at least twice. So s dot split at, oh right, size minus r size. So if r size were 2, and yeah, this makes sense. If r size were 2, we'd be taking 2 elements off the end of the list. So it would be 9 minus 2, which is 7, and that would give us elements 7 and 8, which are the last 2 in the list. That makes sense. Cups. And then we'll say middle picked up R and L, let's call them. S split at, and here it's just L size, right? L size of left. I think so. Now I need to concatenate the 2 picked up lists, which is simple enough. Actually, how do you concatenating 2 sequences is just an operation that makes sense. I could just concat both of them together. You know what though? Let's do it. Let's concatenate rather than like taking the cups that are not held and then adding some of them and then adding the rest. Let's make a single list which is combining both of them. Getting us all 3 cups before I like get lost about which is which, because it's a little confusing that picked up R actually goes to the left of pickup L. They were picked up from the right side of the sequence, but that means they're the leftmost cups conceptually. So let's let picked up equal picked up R picked up L. Now, one thing I don't understand is what's the difference between this operator and the monoid append operator? Like, shouldn't it? Surely sequence, is it not called size? Length? Yes. S, did I get element index wrong? No. What? Element index L's. Oh, it takes its arguments in the other order. No? Takes an A, which is what we're looking for, which is an int. And its second argument should be seek of A. Is it like... But shouldn't it be this? It expected a seek of functions because I called it with this cups, but shouldn't this one be shadowing it? What if I did that? Like, it's still wrong, right? Yeah, okay, so shadowing wasn't the issue. What the hell? Elem index L. That's weird. Let's try this in the REPL. Am I like, what am I misunderstanding? Let import data sequence, whatever. Let cups equal s dots from list, because we imported unqualified, of like 1, 2, 3 as a seek event. Cups, okay, yeah. And then I say elem index L of 2 cups. This is just 1. That's correct. So what are you so mad about here? Like, I'm not insane, right? I'm gonna copy paste that name here? I didn't like spell it wrong somehow and my eyes are broken? No. Okay, let's... This is not gonna make any difference. I'm just testing it to make sure I'm not crazy. It's the same problem. Am I using the wrong function? It's called elem index L. I can't be the wrong function because I tested it in the REPL and it's right. An A and a seek of A. I have that, an A and a seek of A. Oh, you know what? Is it like inferring the wrong type for index because of something wrong somewhere else in the I bet it is. I expect this to be maybe an int. No. I can't like put a type here, can I? No. But I could put one here to like tell it, yeah, that really isn't in. And it's still saying this is the line that's wrong. It's obviously not wrong. Did I destructure the game state backwards? No. Cups is here. Expected type. Do I actually need parentheses here all this time? No. So it's saying, well, you gave me a seek of int, but I thought you were going to give me a seek of functions. Which makes no sense. Oh my god, okay. This was supposed to just be label. This is why I hate that records have accessor functions, and that's the only thing they do. Okay. You know what? Forget this garbage. I am not going to. I'll just like, if I ever destructure these wrong. Okay, you know what I'll do? Fine. Oh, actually, it might be nice to just have indices and labels as separate new types. I'll have to, yeah, I'm gonna do that. That's the kind of thing you can get mixed up easily, and it's nice to have the compiler to help you. So let's say new type index is index of int, and new type label is a label of int. And now I won't have to have these stupid accessor functions, but I also will have the compiler checking me to make sure I don't mix up indexes with labels except when I intend to, which should be never. So we have a seek of labels, and we have an index. No. We have a label. We were keeping track of the currently labeled cup. Got it. Okay, and everything we wrote is actually still correct, which is very nice. And I haven't had to do... Well, wait a minute. This shouldn't type check. Why does it type check? Line 26. I'm not getting fly check for some reason? So I can do this. Oh, actually, this just gives me indexes. Right. So I have an index. All right, I'm closing Emacs again. Yes. See if it like comes back and I have fly check again. No, I don't seem to for some reason. Ah, there's something wrong down here. That makes sense. Okay, the problem is something was wrong down here, so it wasn't highlighting what was wrong up here for some reason. Yeah, so it couldn't. This is what the error I knew was in the file, and I couldn't figure out why it wasn't telling me about it. Is that I didn't give these eq, which I think I only need for label. But I guess I want show anyway. Let's give one for game state as well. Oh, look at all this yellow. Amazing. Yeah, of course, everything's unused. That's fine. Interestingly, I only used index once. That kind of surprises me. So what I want to do next, I did use size a couple times, so that's fine. Let's figure out the index of the destination cup, which should be subtracting 1 from the current cup, I think, right? Let me just check the rules on that. Cup with a label equal to the current cup's label minus 1. So we could honestly use a set to like test to have a quick like way to an efficient test for membership in the set of picked up cups, but there's only 3 things in it. It should be it should be cheap enough to use a seek. So what we want is to compute a new destination cup. And I want the destination label to be the first not picked up. Well, let's call it on table. There you go. Iterate deck of label where deck of label L is actually we want to drop the first label because that's actually the current cup itself. Is label of L minus 1. Oh, don't call it L. Call it X. L looks too much like 1. Mod S dot length of middle. Those are the ones that are still on the ground. That are still on the table. And then we have on table of X. Call it C actually. So it's a whole cup. Or it's a label, I guess. Yeah, sure. Is actually not S LM middle. S, it doesn't have LM. How do you test for I mean, I could use find index or something and test whether it's a just. Scans? I don't really need a scan. I could just convert it to a list and then use elm, I guess. Sure. Oh, not table labels, but picked up. Call it unavailable, I don't know. Unavailable is to list, which we'll have to import in a moment, from picked up. Import data foldable to list. Okay. So that seems plausible to me. We found the new destination label. And now we need to convert that to a destination index, right? It's kind of interesting. I think I like maybe this whole idea of having index be a separate type is like not that useful. because I can just use int for that, and that's what seek is using anyway. And if I ever mix up a label with an index, I'll still find out because label is itself a distinct type. So let's now let destination index equal just the destination index equal S, I've already forgotten what the thing is called. lm index L of destination label middle is what I'm calling it. Okay. So now I have the index at which I wish to place my new cups. And I will split at that index. Before after equal s split at but I won't use they get placed immediately after the destination. So destination plus or destination index plus 1. And then middle is what we're calling it still, right? Now I have a before and some things to add and an after. So I will say cups prime equal, actually I can just return cups prime, I think. No, it's supposed to be a game state, but I have the label as well? That's fine. I'll use cups prime. Is mconcat of before middle, no, before picked up after in game state cups prime destination label. It all type checks. There's probably some warnings about incomplete pattern matches. Surprisingly not. That's a little odd. Okay, so this is kind of a lot of totally untested, awkward index fiddling that could easily be wrong. Let's test it. Let's test one of the inputs from the puzzle, the test input. Let's suppose state equal prepare of 3, 2, 4, 1, 5. And we look at state, and it says 3, 2, 4, 1, 5, and we're looking at 3. Yes, makes sense. Now if we now set advance of state, oh, that's exciting. Already it's busted, huh? At line 33. Huh. I mean, we can import debug trace and see what's going on. And right here is where it broke. So let's look at what the state was going on. Actually, I guess it has to go here, right? Trace show of, let's produce a tuple of middle picked up and destination label. Oops, I meant to go to this buffer. State is that. Advanced state. Divide by 0. What? That's not good. Okay, I mean, let's trace show of R size, L size here. We'll just say advance, so I don't have to keep entering 2 lines at a time. 4 minus 1. Okay, I did something wrong already there, huh? Oh, yeah, that's true. That does make sense, doesn't it? There are 4 cups to the right of where we're starting, and if you subtract that, if you say, oh, I was going to take 4 from the right and I want to take a total of 3, well, you better take minus 1 from the left. That's no good. So we really just need to put in here a max of num cups moved and that number. Okay, it's still wrong. Min. I always get these confused. Mix. I know it's like the easiest thing in the world. Everyone knows what max and min mean. But I was thinking max is like, oh, give me at most this. No, this is the maximum. Don't use any more than that. When it really means, oh, pick the larger between these two. Okay, so anyway, we made progress from list of 3, 0. It says I picked 3 to take from the right. Okay, let's trace show. Oops. I guess it kind of has to go here, right? So it says, uh-oh, it says I picked up all the cups. I picked up 4, 1, 5, 3, and 2 in this wacky order. That's no good. S split at, okay. So size here is 5. And we know that R size was 3. So we said to split at 2 the cups. Well, I mean, okay, let's do a bit better here and say, like, let's just show me left, middle, right? Or we don't call it right, do we? We just call it picked up. Okay. So what did we wind up with here? Our left is 3 and 2. I actually don't even know if that's right. I think it is. What was left supposed to be? Oh, I think I forgot to add index somewhere. Yeah. Because I've computed how many cups we can take from the right, and therefore how many we must take from the left. But I don't take them from the right end of the sequence. I take them from the current label, index, whatever. So I have to split the thing up even more. But why exactly do I get this wrong behavior? I said to split at size, which is 5, minus r size, which is 3, and I get 2. That's, I mean, wrong, for sure. Isn't it? I forget what we're supposed to do. We're supposed to pick up 2, 4, 1, right? The 3 cups immediately clockwise of the current one. So that would be 2, 4, and 1. Yeah, okay. So that's wrong. So it's wrong, but it shouldn't have it shouldn't have caused a problem. We picked the wrong ones to pick up, but who cares, right? Oh, but maybe I removed too much from the list because I computed, I don't know. I mean, our L size was 0, so then we said, oh, this is what's wrong. I got the 2 sequences mixed up. The ones that are left on the table should be the right half of that split. Now, there's probably something else wrong. Yeah, but we got a bit further. So what is this? The third thing being printed is left, middle, and picked up. So it left 3 and 2 on the table. Middle is some, like, label 0? Where did that come from? The 0's not even in the dang list. Oh, well, but I printed picked up. What? I mean, that makes sense. If you're looking for label 0, you sure won't find it. Oh, yeah. That's true. I think. Wait. Well, okay, there's like several things wrong, I think. Yeah. So, okay. There's some problems with how I choose the destination label, which is that I'm taking x minus 1 mod the length of the middle. But you know what? That's like crazy. I should just take the length of the original set of cups plus 1. Because if I have a set of 9 items, then I want 9 to be a valid element. I don't want to mod it like I don't want to mod it down to 0 and never choose it. And furthermore, saying that it's not one of the cups I picked up is like insanely greedy. Why not just look at all the cups on the table and make sure it's one of them, right? Again, a little expensive, but our list has size 6. Like, what's the problem? So we'll just say it's elem of middle, which I believe is the remainder. Okay, now, this did the wrong thing because we still haven't fixed the problem with how we split the input list up, where we start the cut. But it produced somewhere a meaningful result. Although it's hard to tell what it is because of all this garbage that we printed. But I think it's from list of this 32415, which, by the way, was the original input. We basically just picked up these 3 and said put them after 2. So everything was correct except the 3 we picked up. We should have started here, and then we would have put them after 5 because 2 doesn't exist. Okay. So we just need to adjust how we select the 3 cups. So what is it that we're meant to do? Well, okay, let's... How many places do I actually have to cut the input sequence? I guess I need to cut it 4 times, right? Once right after the current cup to begin the set that I'm removing, and then once after our size, that plus our size. Or split the right part of that at our size, which I guess is clearer. And then do the same on the left. Split it once to indicate do I need to split it twice at the left? Am I crazy? Yeah, I might, because I might be taking... I don't know, maybe I don't. Am I, like... Because on the left, we know it's... Yeah. On the left side, we know it's bordering the edge of the sequence, so one of the cuts would always be empty, so you don't have to do that. But on the right, it might be starting in the middle, and it might be overlapping the end, or not, so you need, like, 2 cuts. Ugh. This is definitely a messy function. And it's not as, like, nice as I thought it would be to, like, model moving around the cups instead of trying to do something clever with indices. But I feel like if I were trying to do something clever with indices, I'd have just as much trouble. Okay, so we have to do some things. I wonder if working with R size and L size was premature. If it would be better to just say, starting at the index, which is the current index plus 1. Just split the list there and see how many cups you get. And that'll tell you L size right away, right? Or it'll tell you R size. And from that you can compute L size. So let's say picked up R, left picked up R. Call it kept R. I don't know if I'm gonna need it. Equals S split at of index plus 1 of cups. And now, the only thing I ever ended up needing L size or R size for was computing L size, right? So let's just say R size is what do you get if you ask data sequence to split itself at a... Okay, it's equal to take IS, drop IS, and what does take do? If the sequence contains fewer than I elements, the whole sequence is returned. Yeah, that seems right. So now, I think I just want to split this at the index 3. I don't know, call this right. I'm running out of sensible names. Middle picked up R equals S split at num cups moved right. What are you mad about? I have another thing called middle. That's fine. I'll be deleting it in a bit. So yeah, now I can say L size is num cups moved minus S length picked up R, right? So we picked up some cups from the right. And now I can say picked up L kept L? Equals... Oh boy. I have to do some fancy stuff, I think. I have to say S, I mean, it's just S split at of L size, but I think that the sequence I'm picking up from should be... Hang on. This is backwards again. We'll call it remainder. I don't know. So we have this kept R. What a terrible name. Call it middle? Going nuts here. Middle right, okay. So the stuff on the middle is like being kept, kind of. And also the remainder is being kept because it's too far to the right. So what I want then is middle. I'm gonna look at, like, what is this? Why does this function exist? Why don't we all just use the monoid operation? So if I look like the source for this, I don't know, let's also look at the source for the monoid instance as well. So it calls append tree, whatever, and I assume, yeah, mappend is just this. So we don't have to use this wacky operator. We can just, I assume this came from a time before like monoid was as commonly used in Prelude or whatever. So we can just use the ordinary append operator. Middle remainder. Right, so the cups that were too far left to be picked up, and the ones that were too far right to be picked up. The thing is, if remainder is non-empty, then L size will be 0. And so splitting at 0 from there is kind of stupid, but sometimes it won't be 0, so we're just going to do this. And I think we can just say kept here, in fact. And I don't end up needing L size or R size at all. And I don't think I don't need any of this crap. Right? I mean, maybe I'll regret that, but... So, show me... I don't know. Like, maybe show me nothing here and see if it, like, parses it all. Actually, we changed the meaning of middle, but didn't update usages, which is, like, super dangerous. Let's just rename middle, okay, and update these. Kept. Oh. Elm works on sequences because they're foldable. Sure, that seems fine. So this middle is actually what we wanted. We want middle prime. But here, this destination index is... We don't need this one because it was just part of our show. LM index destination label, and we're calling this kept, the ones that are still on the table. Split at the destination index plus 1 of kept, the ones still on the table. We have before, picked up, and after. I don't know, this seems plausible. Size is unused? Yeah, I mean, I guess it could have been used here. It probably should be, right? Size, there you go. Okay. Label 35214. Current label 5. Is that correct at all? Oh, this isn't actually... They don't actually give us any workings of this example. That was just like to help us understand what clockwise means. But okay, let me like think about this by hand. Let's get rid of the trace shows. I'll actually leave them in, but just have them show unit, so that it's easy to reinsert new ones, I guess. I don't know, it's kind of dumb. Okay, so we said 32415, and what actually happened? We should have picked up 241 and put them after 5. Yes, this is correct. Because 5 is the only other thing that is not part of that isn't 3 and isn't picked up. And that's what we got. We got 35241. Okay. So let's test with our actual, like, with the test input they give us. Just real quick here. Let's see if we get the right answer for that as well. Oh, I wanted to get rid of the trace shows because they suck. So, after this, our label is 2. That's our current one. Yeah, and it's supposed to be 32891 54, etc. Okay, so we did that right. And then then it all is not correct according to the example. Why not? Our label was 2. Three, 2, 8, 9, 1, 5, 4, 6, 7. Yeah, so it was perfect after the first step. After the next step, label 3, 2. Oh, maybe I'm... Oh, I think I just misremembered what you're supposed to... I misremembered part of the puzzle definition. The new current cup is immediately clockwise of the current cup. That's not what I implemented. It happened to work for the first one, but I said it's the destination label, which is wrong. It should be the cup immediately to the right. So it should be like s dot. I assume that's how you look up something by index, right? They call it index. Okay. Wait, what's the difference between index and... Oh yeah, sure. Index, S index, and it takes the seek first. Cups prime of I actually have to go looking for the index of the... So this is our index prime, I guess, which is, or it's going to be the index of the old current cup. And what did I call it? Label? Label. In cups prime. And we just want to take index plus 1 mod. I think we probably need more parentheses here, actually. I don't know, what's... Someone did set infxl mod 7, right? Which is the same as division. Okay. Someone wanted to make sure stuff like this would work, right? Mod size. So now we've produced 325 467 891, and 5 is our current cup, which is exactly what it says we're supposed to have here. So it starts getting interesting around move 7, right? So suppose then that we test that real quick. We'll iterate advance. And we'll look up. We'll drop the first 7 things. Index out of bounds. Okay, great. We broke it. And uh-oh. A little earlier than I thought, huh? Huh. Show me the first 4 that led up to this issue? Because the issue doesn't look like what it was supposed to, I think. We looked at the first one. 328915467 label 2 makes sense. That was just step 2. And then step 3, this is like our, okay, so this is move 1 is just the initial state. This is move 2, 3, 2, and we've vetted this one already. Here's move 3, and the state should be 3, 2, 5, 4, 6, 7, 8, 9, 1. That looks right, and it should be looking at 5, which it is. Next, it should be well, one thing to point out is that we can't necessarily assume that our output should look exactly like the puzzle's expected input, because there are multiple reasonable ways to represent the data, right? The cyclical list, there are numerous correct ways to implement it, and just knowing anyway. But the point is, we have the wrong data anyway. So at the beginning of this is the beginning of move 1, 2, 3. Yeah, beginning of move 4. We have, well, what we should have is 7, 2, 5. That's what they have on the left. Mine are in a different order, but starting here is fine. 8, 9, 1. 3, 4, 6. That's correct. Okay, so my cups are in the right order. And the label that I'm looking at is also correct. Okay, so we didn't... I thought I had made some mistake earlier here because my cups were showing in a different order than in the puzzle's example. But that's just because I happen to wrap things around differently. Not a big deal. The issue is that once we compute from this, we break stuff. So let's... trace show is going to be a bear, isn't it? Let's just capture this state. We'll just put it here. Buggy equals that. There you go. Get rid of that backslash that appeared there for some reason. Why? What? I don't totally understand what it's mad about. Oh, S from list, I see. So now we have a buggy game state, and if I just say advance buggy, it breaks. Okay. And I can start putting in some trace shows to figure out what's going on wrong. Which is the line that breaks? Index 9 at... I don't actually know what index, where in my code that happened. But okay, it must be at the end. Because that's the only time I use index, right? Oh, well that's exciting. Maybe the parentheses maybe the parentheses were put in the wrong place? No, that didn't change anything. Why? Trace show of cups prime, and index prime? Wait a minute, no error now. Did I not recompile it when I put the parentheses in? Yeah, that's what happened. So if I just remove this trace show, advanced buggy advances fine. And what does it advance to? The label is 4, which is correct. And starting from 4, we should read, where the hell is 4? 4, 6, 7, 9, 1, 3, 2, 5, 8. Yes, that is correct. Okay. So it seems like we handled wrapping around the end all right. Let's actually run our program now, or write part 1, I guess. So we're supposed to do 100 moves. Clockwise from 1. Starting after the cup labeled 1. Okay. So our output is a string, of course. Let final equal, iterate advance state 100. And 1 index equal, let's say just s lm index l label 1 of final. I guess I want digit to int, huh? Or int to digit? And then I want to map a function map into digit dot position, maybe, over 0 up to s length final minus 1. Game state, and at position of I equals I plus the 1 index mod s length final. But then I have to actually look it up in the list. S index final of that. Oh, that's true. At position to int, or no, let's just, since I have a new type, we'll do the traditional thing and call it get label. Redundant? Yeah, sure, but I like it. So suppose then that we said stack run. What would occur? Would I get 9 digits? I would like 9 digits. Yeah, I mean, sure, could be. Let's see how it looks. That's not the right answer. It's too high. Well, I don't know if that's really a meaningful judgment of it. Okay, well, you know what I should really have done anyway, is test it on the test input that we were given, and like change the number of runs. Oh, no, they give you 100. Okay, so let's. Well, it would be. I assume the answer would be wrong, right? Starting. After the cup labeled 1. I started at the cup labeled 1. So that's actually enough to make me believe it might be right. But in the meantime, let's write our example here. Here's the input they gave us. Change our main to read from example and run that. It makes sense that it should be after 1. Ooh. Uh-oh. Non-exhaustive patterns in 1 index. The label 1 was destroyed? Oh. Okay, first of all, I copied the wrong thing. The example they were giving us to work with was actually this, and they were saying this is the answer you should have gotten. So actually what I then should do, I guess, was not add 1 here. Just leave that where it is, and just start at 1. Because they don't actually... The 1 is implied. Okay. So if I say stack run here, we get 673845529, which is exactly correct. Okay. So I'm pretty happy that this is going... I expect that this will probably be correct. But we definitely are not like in the mythical land of run it the first time and it works, right? We had a lot of bugs today. Just sanity check this as it has 8 numbers, none of them are 1, and they're all different, so it could be a correct answer. There you go. That's the right answer. Okay, we'll commit this hot mess here. Didn't end up using toList, huh? I don't need buggy. Anything else I should do, HLint? I'm going to leave that where it is. Okay, this looks fine. Day 23, part 1. Finally. Okay, on to part 2. Due to what you can only assume is a mistranslation, you're not exactly fluent in crab. You were quite surprised when the crab starts arranging many cups in a circle on your raft, 1 million in total. Your labeling is still correct for the first few cups. After that, the remaining cups are just numbered in increasing fashion, starting from the number after the highest number in your list and proceeding one by one until 1 million is reached. Okay, this is good. This is a good part 2, because it means that... Oh, it's also going to do 10 million moves. So you really have to do things fast. But it means that using a good data structure is important, which we're doing. I will have to change, like, to use a set instead of a seek for the cups on the table, which is fine. I talked about maybe needing to do that, but we didn't need to for part 1. Anyway, so, and then keep counting up from 6 until 1 million is reached. In this way, every number from 1 through 1 million is used exactly once. It's going to do 10 million moves. Hide your stars, 1 each, under the 2 cups that will end up immediately clockwise of cup 1. I see. So we didn't need to parameterize by number of cups moved, which is nice. I thought I might have to. In fact, the advance function can almost remain exactly the same. The only thing I need to change is this function. On table is using elem, which is inefficient. Ooh. All these elem indexes are expensive as well, right? Yeah, that's a bigger problem. I wonder, could I arrange things so that elem index was so that the index of the current cup was always 0? The problem is, even if I did that, this elem index is hard to get rid of, isn't it? And if you do 1 million steps 1 million times, 10 million times, that's like 10 trillion operations, and that's going to take a long time. You might, I don't know exactly how long. Maybe these operations are fast enough that you could do it in like hours, not weeks, but it would be long. So something smarter is needed. Huh. So, like, I'm kind of imagining, what if we had a map from label to index? That would be great. The question is, how do you keep it up to date? Every time you remove or you move 3 cups, you have to update the indices of a lot of things, right? Huh. Even if you keep... Yikes. Even if you tried to keep the the current cups index at 0, you would have to update the map entries for, on average, like half of the cups, right? Or, well, maybe most of them can stay the same? You take 3 cups from near the beginning of the sequence and you put them somewhere at random, right? More or less at random. Somewhere unpredictable. Then the cached indices for some elements could remain the same or be offset by 1 if we could like implicitly track, okay, we've moved through 1. You know, you could track offset. I don't know. Maybe keeping the current cup at the beginning is not a good idea. But the point is that on average, about half of the cups would have their indexes shifted by a different amount from the other half, right? Those that were before where you inserted the new cups and those that were after. So keeping a cache up to date is not easy. I mean, I'm like starting from the supposition that it's impossible to do scans over the 1,000,000 cups at all. Maybe that's not impossible. Maybe it's tolerable as long as you don't do too many of them. Like, what if you only did 1 per move? I still think that's like too much, right? That's the 1,000,000 times 10 million. That's like a 10 trillion steps. Like, even if your computer can do, you know, a few billion operations per second, that's still 1,000 seconds, and that's assuming it's only a single clock cycle to do 1 move, and so that's like hours. So there's no way that approach is going to work. You have to figure out something smarter. And I might not be smart enough. Shifting is also like no bueno here, right? we can't like use a ring buffer and shift half the elements by 1 every time that we move 3 cups. Well, I don't have any bright ideas right now. I'm going to go away for a while and think. And I'll come back and tell you whether we're going to finish and do part 2 or whether I'm going to give up. So I'll see you in a bit. Okay, so I didn't think of anything clever, and instead I looked for advice on the subreddit. Since I'm doing these like kind of late, there are answers up there, but I'm doing this one like over a day late. In addition to uploading it late. So anyway, point is there are already answers out there, which is sort of nice. I didn't read anyone's code, of course. Well, not of course. I guess if I had needed to, I could have. But I found a description of the right data structure to use, and that's enough that I can make sense of it and should be able to implement the algorithm. The idea is to have an array. We'll use an int map instead because it's well, no, I mean we could use an array. Yeah, sure, why not? Where the important thing to like realize that I did not is that you don't want to think about indices at all. If you have to do anything by index, you're just like out of luck. I mean, I don't know. Maybe you could do some stuff with indices, but in particular, you never want to search, and that I knew that was why nothing was getting anywhere. But if you're never going to search for anything, you don't necessarily need the indices. All you really need is a way. You don't need to know the absolute position of any cup, right? And my solution, I just kind of like the absolute position of cups goes crazy. I'm just like putting stuff at the front of the list whenever I feel like it, so I'm not tracking it. But I do still address cups by their indices. And I shouldn't even need to do that. What I should have, all you really need is a way to find out, given a cup, what is the cup after it. And that's it, right? You might say, well, what about a way to find an arbitrary cup? Don't need it. If you can find the cup after a cup, you don't care where the first one was. So the algorithm then, or the data structure then, is an array where when you look up cup C in the array, the value that you find is the index in the array, or the I guess the index in the array or the label, it's kind of the same thing. The label of the cup after that one. And so if you wanted to traverse the entire list of cups, you could start at 1, index, that gives you a new index that gives you a new index, and so on. But importantly, it lets you, for any cup, look up quickly what comes after it. So when you say, I want it, my current cup is 5 or whatever. You say, okay, well, let me look up what comes after 5. It's 9. And what comes after 9? It's 12. And what comes after 12? It's 107. Great. Now I've found the 3 cups I'm going to pick up. And then you can quickly find right. And then say, I forget your current cup already. Did I say it was 5? We'll look for cup 4 and change its next cup pointer to be the first one we just picked up. Call that A, because I already forgot what number it was. And we'll change the next cup pointer of the last cup we picked up to be whatever was pointed at by 4 previously. And then that's it. That's all you do with the step. You look up like 3 things in an array. I don't know, 4, something like that, and edit a couple pointers. So I think that's a good thing to use an array for. I heard people talking about who had done it in Haskell about how using int map, it takes like a bit over a minute to solve part 2 with the efficient algorithm, which is worse than people in immutable languages were doing. But also, like, it's just not much harder to use an array than an int map, so I might as well use an array, right? That's what I think. So let's just go edit our Cabal file. I don't need containers anymore. I just need array. Is it arrays or arrays? I forget the name of the package. It's called array. Okay. So we're going to be like throwing away all of this. It's all gone. Pretty much, right? Can't reuse anything from part 1. Yeah, hey, we can reuse this. There you go. So, num cups moved. That's a good one. We can keep that as well. So let's define then. Oh man. Type game state of S. Yeah. We have to parameterize it by the state, the st type. Oh, I need where's run st? Is it in? It's in base. Okay, cool. So I don't need to import that. It's st. No. St. I might as well use unboxed, right? Stu array of int. Or what order does import data array? I've already forgotten what the packages are called. Data array st? No, data array unboxed. No, data array st. Okay. Data array st, stu array. And some other stuff, I forget what. I don't need run run stu array. I mean, I guess I could. But I can just put part 2 in state in st as well. It doesn't really matter. Part 1 and part 2. And it also exports marray. So I'll need new array, read array, and write array are the main things, right? Actually, I'll probably just use new list array. Read array, write array. And I shouldn't need map or anything like that, right? Okay. So this is an stu array of s, int, and int. I wonder if could I actually use my distinction between label and index here? I don't think I want to anyway. But I'm not sure if you could have can new type wrappers, do they automatically derive unboxable or boxable, or I don't know, maybe you could, but I don't need to. So this is like our new type, I think. We take an array and we produce in ST a new array parameterized by that same type. Actually, our game state needs more than that, doesn't it? Oh, and our input can't be a game state anymore. It needs to just be like a list of int, which is the initial things we were the front half of the array, not the front half, the front 10 elements. And it takes a game state of an STU array int and an int, which is the current cup. Import control monad st. We need st and run st, I think, is basically it. So advance of game state array current equals. And I think we just have to immediately start in do. There's not much else we can do that's interesting. Do. So we need to pick up the next 3 cups, right? That's simple enough, I think. I mean, actually, we don't even have to change the middle cup, right? Well, let's just let first, which will be the first one we're picking up, is read array. What order does it take its stuff in? It's from marray. Read array takes the array and then the index. So array cur. That is the index of the first cup we are moving. Okay. And let's say second is read array first. Third, read array second. So these are the 3, the indices in the array of the 3 cups we are picking up, not the 3 cups that come after them. So I need to read one more and say first immobile read array third, right? That cup is staying put. And in fact, it is where I need to update the current to point to, because these 3 will be gone. Then I need to find I need to choose the destination index. So dest index is one index arrays suck. I'll just have 0 point to 0 and not participate. It'll be the first filter not elem of. Now these are the Do I have labels or indices? I guess the current cup that I'm holding is a label, right? I'm keeping track of a label. Ah. Right? And when you look up in this array by label, you get the label of the next cup. So first is the label of the first cup that I'm picking up. Okay, so this is correct. First, second, third. So we wrote this before. I'm going to be reusing this, I guess. Well, let's let moving cups equal first, second, third. Okay. Indent that, please. And deck of I equals, I need to be careful to deal with 0 again, but actually I think it's, I will just say it's I minus 1 mod I have to, we'll put the size, oh man, okay. Current and size are both int. Size of mod size plus 1. Is this crazy? Because I want to make sure I don't hit a 0, right? If I get the is size the number of cups or the size of my array? Because I'm making the array hold one useless element at 0. I think it should be this, the number of cups, right? So that means my array has, let's say, 10,000,001 elements. So if I mod 10 million, I think I'm doing something wrong here. I'm just subtracting 1 and then adding 1 like a complete idiot. There you go. Problem solved. It's not 0 or one of the moving cups. Okay. And then size can just be the size of the actual array. Obviously, we could just read it at the beginning of each iteration, but like, why? It's already right. We already can know it. Oh, can I like, I could save all this stuff strictly, couldn't I? Since we're like trying to be a little performance. Is that how you do it? Seems to be. No? Haskell strict data type. How do you... What do you have to turn on to make this legal? Strictness annotations. Haskell enable strictness annotations. Explicit strictness. Yes. It's called bang patterns. That's what I wrote. Okay, I must need to like restart. Something. No, it still hates this. Oh, does it go there? I see. Okay, I must have accidentally hit my stop recording button a minute ago. You didn't miss too much. I just finished writing this advanced function, and was in the middle of remarking that it seems rather nicer than what we had before, that was dealing with sequences. There's actually less having to fiddle with indices and explicit splitting when you can just update pointers of the beginning and the end. So the idea, I forget how much you guys already saw. We read the 3 cups that we were picking up, and the first cup that's not moving is something we need to know. It's what the last one used to point to. And make a list of the cups that are moving and add 0 to the front of it, and use that to find the destination index. It's the, subtract 1 from the current until you get to something that is not either a 0 or what we're already moving. And do that mod size, which is fine. I could avoid all these. I could avoid the operator precedence issues by using subtraction outside the parentheses instead of inside. Anyway, and then we read what used to come after that cup, and then we do all our writes. After the current cup is the first cup that didn't move. After the third cup that moved is now what used to come after the destination cup. And after the destination cup is the first cup. And I think we're done. Oh, I changed the type signature here. I had it returning a game state, but I don't actually need to do that because I'm modifying the array in place. Huh. Oh, no. I actually do need to return the current element. I need to change this. Now, I could extract that out from the type, actually, and have like, then I could partially apply advance to the array, basically, the array and the size, and just iterate and get a function from int to st of int, basically, and then apply that on itself some number of times. That actually seems kind of nice. If I'm going to do that, I guess I might as well not keep the size and just read it at the beginning of this. Yeah. So let's throw away this entire game state nonsense. I mean, it's not nonsense. It was fine. Get bounds of no. How do you look up an array's size? Bounds? Get bounds. Oops, what am I doing? It's not a game state, it's a cups of S. 0 size. Now size is the maximum you're allowed to it's the maximum that's actually in the array. Unlike every other language, Haskell's array, Haskell, when it uses bounds, they're like inclusive, not exclusive at the top. Let size, oh, whatever, I can just move this into the other let. Size equal upper -1. And then we can return pure of first immobile, the one that is now after the original current. That seems right. So we could test this. It's a little awkward to do in ST, of course. I mean, actually, we haven't even written like the functions to produce an initial game state, so maybe I should do that first, huh? My input is still a list of int. I agree with that. So part 1, I guess I need like iterate m again. Iterate m takes an int and an a to ma, provided that m is a monad. Although, like, don't I just need applicative? No. Right? I feel like I think I must need monad. I don't know how to write it without it, so and it gives you an n with a back. Iterate m 0. Oh, I have an a as well to start with. X equal pure x. nfx equals xf. Iterate m n-1 f applied to that, right? Yeah. So part 1 let's say. Just throw all this crap away. I don't know, I might need at position or something. Equals run st of do? Sure. We'll probably want to do that. Array is new list array. Does that just take the arguments I would assume it does? It wants a bound as well. So indexed from 0 up to... Oh, I just thought of something funny. I could make my array be 0 indexed even though I'm throwing away... Well, I don't know. I want 0 to point to nothing anyway. No, I don't need 0 pointing to nothing. Well, but I want to be able to look up array index 1 and have it give me something meaningful. But I don't need a 0 to have that be true, right? I can have my array indexed starting at 1 if I want. Is that a good idea, or am I just going to get confused? Yeah, let's just do that. And then, like, I just have size. I don't need this crap anymore. But then it's gonna, when I take 1 and subtract 1 from it, yeah, I'm not going to mess with that. I'll have it be 0. Actually, this is still wrong. Because when I subtract 1 is the smallest element in my array. And when I subtract 1 from it, it won't wrap around like I wanted it to. So I actually have to subtract 2, then do the modulo, and then add 1 if I want it to be in the right coordinate space. Okay. That's kind of gross. But given that I'm doing that, I don't need the 0 element for anything anymore. Okay. So from 1 to 9. Seed? I think, because my seed is just a list of int. And I don't even need the index, so let's just throw that away. Iterate m. We were doing this 10 times, 100 times in part 1? 100 times. Of advance array. Starting with 1. No. Starting with the first item in the list. Okay. So now I think much of what I'm gonna do here is similar, right? I have to figure out where the 1 is, which is like kind of yuck. There's no elem index, which makes sense. It's not a sensible thing to write for arrays, really. What is the... So we have all this stuff for writing with like M arrays, which you can only do in state. But then I see, it's safe, so we could use unsafe freeze, I guess. We would get back I array, which are immutable. And all this stuff happens not in any monad, which is kind of nice, right? Yeah, maybe. I don't know. Why don't I just like not do that though? Like dealing with indices at all is kind of lame. Let's just call getElems, and it'll give me a list of all the items, and then I'll just like rotate it until 1 is at the front. It's a little like silly, but it's fine. GetElems of array, which has been now mutated. Let oriented equal head of drop while not equal 1 head. Iterate rotate elements. I need getElems here. Now that I have the list oriented, we'll let rotate x's equal x's x. Very inefficient, but that's okay. This is only for the small input that we're doing this. Finally, we can say pure of map int to digit tail of, oh, I see, oriented. Is this type check at all? Ah. Our input now can just be digits, and we don't need the first for anything either, do we? I handled that in part 1 anyway. Yeah, that kind of seems simpler, huh? Unexpected strictness annotation. Fine. It makes sense. It only would make sense in a data structure, right? So we need get bounds. I spelled that wrong. Oh, dec needs a function. No? I'm giving it a function. Here, current. What is cur? Cur is an int. Dec had the wrong types. Label not in scope. Yeah, I agree with that. Some type is wrong here. Oh, right. fx. There you go. So this compiles. What are you mad about? Yes, pattern match is non-exclusive. That's okay. I mean, I guess we might as well try running it and see what happens. Probably some explodes somehow. No, it gave me back complete nonsense. Okay. I mean, in fairness, there are 8 numbers. Like, that's part of the way there. So let's get back to some REPL testing, shall we? Test. Gosh. Test is a list of int. Test is run st of do. Array will take, let's say, new list array from 1 to 5 of, well, I mean, I don't know, let's use 1 to 9. We'll use the example input they were giving us of 3, 8, 9, 1, 2, 5, 4, 6, 7. That's the test case. Yeah, sure. You don't. I'm not done. That's correct. Advance array, and we're initially looking at the cup labeled 3. Oh, hang on. This is an insane. Yeah, I just made this. This is not. This is not what the array is supposed to look like. Okay, so part 1 needs to be fixed. Okay, what we need is a function that, given a list, which is our seed, and a size, gives us back the right array. Okay, so let's write that. Init array takes an int, which is the size, and a list of int, which is the seed, and yields a cups of s. STS and cups of s? Yes, I was like, what? That dangling s made me very uncomfortable because it was wrong. It's not how ST stuff looks / works. So test of n and x's as x and the rest is due 1 to n. Let's make it return the label of the first cup as well. Oh, I can get rid of these parents. Let's just call this indices, lookups, x's, I don't know where, and indexes can be computed purely. Indexes equal seed plus filler plus n, the last one in the array, maps to x, the first one in the array. Seed is zip x's with tail x's, I think. Yeah, like if we have I don't know, 3 at the front and then 8, we'll be saying 3 maps to 8. That's not right at all, is it? Yeah, it is. That's what I'm supposed to be storing. 3 points to 8. But that's not actually the format that new list array expects, is it? New list array wants them in order. That sounds way harder. Let's just use a new like non-list array. Lambda index to write array takes the array first and then the index and then the element. This can just be uncurry though. uncurry right array array. Okay. We have to import from data foldable. It doesn't know too many arguments. Too few arguments. What does new array take? Oh, an element to be filled in with. Sure. Fill it all in with 0, I guess. I don't know. We'll just, sure, fill it in with zeros. If there are any zeros left, we'll be very sad. Like so. And filler is zip. No. X points to x plus 1 for each x in length x's. If the list had 9 elements, length x's would be 9, and we should be starting with 10 plus 1 up to seed size plus 1 up to n minus seed size. So if our n was 20 and there were 9 elements in the thing, then 20 minus seed size would be 20 minus 9, which is 11. Oh, hang on, I shouldn't subtract anything at all. Oh, but I should subtract 1? Because the last element, x, the element labeled n should not be written. So n minus 1. And I'm actually only using seed size once here, so I'll length seed. And it's just complaining I haven't returned anything, which is true. Pure of x array? Okay, cool. So part 1 then is not new list array, it's init array 9 of seed. And I can just get rid of this. First array comes from that. You're mad about exhaustiveness, I suppose, here? Yeah, that's fine. Okay, this compiles. Let's see what it does if you run it. I think it's still wrong because my weird set, well, I don't know, maybe my weird set would. Index 0 out of range 1 to 9. Sure. It's kind of error you might expect given the way I wrote this program. I wish I knew where that happened. but it doesn't tell me. Let's bring back debug trace and put back like here. Just see if I built the array correctly. I just want to see indexes. Okay. Six points to 2, 2 points to 4, 4 points to 3, 3 points to 9, 9 points to 7, 7 points to 1, 1 points to 5, 5 points to 8, 9 points to 6. That sounds pretty good. And our range is 1 to 9, so that's fine. Okay, so it must be advanced that's wrong. Now it's like time to test it. That's fine. We were going to do that before and we got interrupted. So test is a, I don't know, a list event. Test equals do, no, run st, so do. Cur array comes from init array of 5, just the smallest one possible. Again, and the example that they give us to work with at the beginning. Well, I don't know. Let's just use the example input, right? 9 and I already typed this out once, but I've deleted it since then. So, oops. 3, 8, 9, 1, 2, 5, 4, 6, 7. Advance array cur. Elms array. Oh, I think I can just do this, right? Get elms. Okay. So if I test this, it'll break, I assume. No. So it yielded 2 points to 8. No, yeah, that's right. 8 points to 5, which is totally wrong. Wait. I'm not reading this correctly. I should have this actually return a list of pairs events so I can read it as A points to B, and yeah, okay. Get a soaks. Does that work? Yeah. Okay, so 1 points to 2. That's also wrong. 2 points to 8, we got that one right. 3 points to 5? This is all completely wrong. Okay. But like, here, like this is the example that I'm looking at and trying to get this. And we actually have 1 points to 2, which is fine. Or no, it's not. That's wrong. That's how it should have started, but 1 should now point to 5. 2 points to 8, that's right. So what did I actually get if we like... Oh, you know what I should do? I should write a function for like pretty printing these. And that's actually what part 1 is using, right? Well, not quite. Or part 1. Did I say part 2? I meant part 1. We can just look at like this, maybe? Wait, is part 1 just insane? Part 1, what is part 1 doing? Yeah, part 1 is nonsense. The way I'm printing this thing, right? I'm asking for the elements, which is giving me like... Yeah, this is not correct at all. Okay, so maybe what I need is... a function that like gives me elements starting with or whatever, and then traverses the array. Okay, that seems useful. Elements from takes an int, which is our starting position, and turn and then a cups of s. There's an sts and int, listed int. Elements from focus array equals do. Equals actually go focus, maybe? Where go... Sure. Go endpoint. Oh, actually I can just call this the endpoint? I need like a start and a stop, and I need to track them separately, right? Go focus. If focus is equal to... No. Equals do? I want to read what's there. X comes from read array focus. And then if x is equal to endpoint, then pure nothing, I guess. Else cons x onto the result of calling go x. Flexible contexts. Why do I need flexible contexts? I'm not sure. Something to do with a helper function that's in a context with this floating type variable, I think. Okay. So test. Actually, I just want to be a list of int. And instead of get a soaks, I want elms from 1. Oh, actually, you know what? It should be pure. I think I'm going to be dropping an element somehow as I've written it. Yeah. Well, okay, that's maybe not the cleanest way to write it, but I think that's right-ish. Actually, I think here we can write just unconditionally put the focus in front once. Oh, hang on. This was sort of important. There you go. Elms from 1 array. Test. Index 0 out of range. Well, yeah. Okay, let's not even advance. Just see if my elms from is working. Oh, I didn't compile. Uh-oh. Init array is wrong. How could init array be wrong? Goes from 1 to n. Do I still have get a soaks? I do. Test. So it produced 1, 2, 3, 4, 5, 6, 7, 8, and 9. 7 points to 0? That shouldn't have happened. Oh. Okay, why would you do that to me? Okay, I did something wrong at the end here, clearly. N Oh, 7 never got written. Oh, I put right. The last element in my input list is not the last item in my list of next pointers. So 7 came last in the list, and there was nothing to zip it with. Okay. Last x's has to point to x, I think. Oh my god, it's huge. Oh, that's because I What? Maybe my trace show is wrong here. I'll just try to get rid of that. Yeah, that's what's wrong, I think. It was printing. No, there's just still a bunch of junk there, huh? Elms from is wrong. Okay, that I can believe. Oh, I put the focus at the front of go where it's applied recursively every time, but I wanted it here where it happens only once. And now we get 1, 2. I mean, this looks about right. Yeah, that's the array we fed in, I hope. Yeah, we gave it starting here 1, 2, 5, 4, 6, 7, 3, 8, 9. Great. And if I advance this once, it just collapses. Oh no. Okay, fine. We can put some trace shows into advanced to understand what's going wrong. We can see, in fact, what writes we're about to make. That's really useful. Trace show. I don't know. I mean, first immobile, or... Oh. Might be kind of nice to just have these in a list, right? So let's say for cur first immobile, oops, third after dest index first. Uncurry right array. Well, let's let rights be this. Trace show rights. So we said change cup 3 so that what comes after it is cup 2. That sounds right. Change cup 1 so that what comes after it is 8? That's not right. It should have been 5. And what about the other right? Change cup 3 so that what comes after it is also 8? Well, that's just wrong. Okay. Let's look at first, second, third. First, second, third. They're 8, 9, and 1. That's correct. Ah! Oh, first mobile's already, it's not in scope yet. Yeah, you got me on that one. So 3, 9, 1, and 2. Yeah, that makes sense. And size is upper -1? That's not right. It should just be upper. I think something went wrong there when we changed our our indexing scheme. So yeah. Okay, maybe that fixes the problem and everything's perfect now. Nope, totally busted program still. Okay. So let's say we get out dest index. What? Is this just like not happening at all? It's not printing this? It's not using size? Destination index is 3. That doesn't seem right. Because, okay, we started with current being 3. Cur is 3. Okay, let's just what are the inputs to this computation? We have cur, and then dest index. I mean, like, those are what I want, right? I don't know, moving cups could be useful as well. So cur is 3, and then dest index is also 3. Dest index, okay. I mean, our moving cups are 8, 9, and 1. Well, that's fine. We iterated decrement. We subtracted 2, and we were starting with 3. That gave us 1. Right? And then mod size left it alone, and then we added, and we got 2. So, oh my god. Head, iterate returns the current element first. So I was just always... we want a tail there, but I'm still not convinced this is actually right. Okay, well, it actually looks fine. 1, 5, 4, 6, 7, 3, 2, 8, 9. That's actually in the right order, believe it or not. Okay, let's run this. I would love for it to be correct. Two, three. I mean, it's not totally corrupted. We forgot to get rid of that junk, but was it the right answer? No, I had a completely different answer. Okay. But I mean, it ran a bunch. That's nice. That's an improvement. When does it start to deviate from the expectation? So we'll say iterate one advance array cur. And this should just take a single step, which is fine. And it should return still the right answer. Yes? Test. Let's get rid of these trace shows. Okay, and that returns like a totally reasonable number. If I change this to take 2 steps, we get taking 2 steps. 1, 3, 2, 5, 4, 6, 7, 8, 9. Okay, that's still right. And I bet this is the first time, well, I don't know. I do 3. I get 1, 3, 4, 6, 7, 2, 5, 8, 9. That looks right. After 4 steps, I'm starting to get a little bit lost. I have 1, 3, 2, 5, 8, 4, 6, 7, 9. That's correct. After 5 steps, 1, 3, 6, 7, 9, 2, 5, 8, 4. That's correct also. So if we were just going to do, if we were going to do all 10 steps that they do in the worked out example, I would end up with 1, 9, 2, 6, 5, 8, 3, 7, 4. That's exactly what you're supposed to have. So what is happening? Is part 1 wrong? Oh yes, of course it is. It's just complete. I didn't rewrite it when I implemented elements from. Elements from 1. Array, right? Okay, and that's the right answer for part 1. Oh, so lovely. So I could just commit this, but I think all I have to do is, like, for part 2, is pretty simple. produce an int. Part2 seed is run st of do. First array comes from init array 10 million? No, 1 million. And then there are 10 million moves. Okay. Oh, I typed that wrong. Then we throw away the result of iterate m 10 million, advance array first. We could maybe extract this to be a function, but I'm not going to. And now we don't want elms from here. We want to read what's at cup 1. I did this again. First, or A, read array 1, B, read array A, pure of A times B. I do have to say, you want a seed, that's correct. Okay, I mean, let's give that bad boy a try. Index 0, out of range. Okay, I mean, this is fair. We didn't actually end up testing the padding feature in our part 1. I assume we would have the same problem if we just said, give me 10 elements. So where is that init array is wrong? So the seed, actually, I want this back so I can debug init array. Although, don't I just want, like, just give me the indexes, basically? And let's just change this to, I just want 10. It'll still break, but I'll have gotten some useful output first, I assume. What are the two things being printed here? Oh, I see. Part 1 and part 2 are both printing, sure. So we'll ignore the first one. Or actually look at the difference between them. Six points to 2, 2 points to 4, 4 points to 3, 3 points to 9, 9 points to 7, 7 points to 1, 1 points to 5, 5 points to 8. And then it gets exciting. 8 points to 6, I guess, is fine. Well, not really. Nine points to both 7 and 10. And remind me what my actual input that I'm giving it is? Or I'm giving it my real input, so... 8. 8 should point to 10. And 10 should point to 6, right? And that's just like totally not what happened. Okay. So indexes is the seed, which is easy. We zip x's with tail of x's. That's fine. Right? That's 8 points to 6 won't be in there, which is what we want. 8 is supposed to point to 10. And then 10 is supposed to point... Oh, this plus 1 is wrong, apparently? Well, don't just make that change, like... Just think before you type random garbage. Last of x's... which in our case, again, is 8, points to x, which is the first one in the list. That doesn't seem right. Oh yeah, it should be n that points to the first thing, right? N is the last element in our filler, and it doesn't have a place in filler to point. So this should be n. But the filler isn't quite right either. I don't think. What are you highlighting, by the way? Binding for x shadows this x. Oh. I think that's fine. So if I just do this, what happens? I still get a busted array, right? Yeah. Oh, we broke part 1 because part 1 doesn't have any filler. I see. So I need to zip x's with its tail. And then I need to construct filler, which is fine. It starts with the length of the seed, which is 9. Okay. I think I see what's going wrong. So the length of our seed here, suppose it was 9. God, this is such a long video. But it's a good problem. I'm not mad about the problem. This is the kind of thing I always miss a chance to do, is like array, I don't know, linked listy stuff, figuring out smarter representations for things. Anything that you can't do with like maps and sets, I like give up. So how, oh my god, my brain is like just not working right now. How do we update, how do we fix the boundary, right, is what we have wrong. Does it matter whether there's filler or not? Do I have to do completely different things? I think so. Okay. So we need to change this to be conclusion, finish? I don't know. And finish if n equal length x's equals this. Just tie the last one to the first one. Otherwise, it's different. It's n to x, I think. Yeah. So that's the finish, that's fine. And what about the filler? Do I need to change the filler? Length of the seed plus 1, so that's like 10, up to n minus 1. This looks right. It just like isn't doing anything when the seed is equal to n, right? Because we're going from length of seed plus 1, which is 10, up to n minus 1, which is 8. Now, that's a little spooky. What if I gave it, like, if I said length of seed is 9, but n is 10, which is my example here. Well, length of seed is 9, plus 1 is 10, up to n minus 1, which is 9, so it still does nothing. Filler is still empty. But I think that's okay, because finish covers that. We say... no, I don't think so. Yeah. We actually have to... We have to add another bridge from the last element of the seed to the first element of the filler. So... last x's maps to length seed plus 1. Which in this case would be 10. And then, yeah, okay. Okay. Oh wow, it went fast. It did 10 million iterations in no time flat. It gave me 10, which apparently 5 and 2 multiplied together, or 10 and 1, I don't know. But anyway, it gave me... This is a little weird. I ended up writing two more elements, even though I only wanted one larger thing. Yeah, something's wrong with that. 6 goes to 2, 2 goes to 4, 4 goes to 3, 3 goes to 9, 9 goes to 7, 7 goes to 1, 1 goes to 5, 5 goes to 8. 9 still goes to 10 instead of to 7. I am getting confused n with like length of the seed or something. Okay, so let's write not indexes, but seed, filler, and finish, so I can tell which of these is wrong. We're running 10 million iterations for no reason at all, just to look at the output of that. But so our seed goes up to here. And just remind me, 9. What's the 9 goes to 7. Why am I now saying that 9 should go to 10 instead? That's nuts. I should be saying that 8 goes to 10. And instead I'm saying it goes to 9. These are just horrible. And so filler is wrong. No, 9. There shouldn't be any filler. Filler should be empty. Yeah. Length of seed plus 1, that's 10, up to 9. That should be empty, right? (10 to 9). It's empty. How am I getting... anything in filler? What's the size of my seed? It's 9, obviously. Well, we can like comment this all out and say pure 10. So we can iterate 10 with the seed that's 9 elements long. We make a new array from 1 to 10, filled with zeros. Seed plus filler. Filler goes from length of seed. Oh my god. Not seed, length of x's. Wait, doesn't that make it even... No, that does fix that problem at least. Now filler should be empty. Yeah. And then I say 8 goes to 9, but actually it should go to 10. Eight goes to 9. So 10 goes to 6, that's fine. Oh, I did the same thing again. I used seed instead of x's. Okay. Now 8 goes to 10 and 10 goes to 6. This looks fine. Let's actually run part 2. No, I could remove those. 27, that seems unlikely. Oh no. It's possible. I mean, maybe cup 3 and 9 just happened to be right after 1. I'll put it in. No, it's not the right answer. Why? What the hell? Okay, well, you know what we can do is we can test it on their example input, right? And it should be wrong. Oh, did I change? I made other changes, didn't I? To part 2. I changed the 10 million to 10. Or it should be 1 million? And then we do 10 million steps with it. I forgot. Yeah, no wonder it was so fast. Okay, yeah, that's enough. Thank you. That'll be all. All right, we didn't need to see the linked list it was gonna print. That runs pretty fast. And it gave me a big number instead of a small number. That's reassuring. That's the right answer. We're done. Okay, well, I guess there's a couple things I should update before I go. We can get rid of test. We know that works now. Oh, I accidentally unindented that or something? Yeah. What am I not using here? Get a soaks and get elms. Well, fair enough. Yeah, that looks good. Day 23, part 2. All right, I got to edit together those 2 extremely long parts and upload that video. Thanks for watching, and I'll see you next time.